Okay, this is the last transformation that we're going to be looking at. So our goal is I can transform y equals sine x using a thing called phase shifts. Now, a phase shift is when we've opened up the x area, the degree area of sine. And what happens is that's going to move it left or right. Now, just like parabolas, now if you remember with a parabola, you had y equals, and we had x. Well, I'm going to put a minus c squared here. So what happened is it moves it in the opposite direction. So in other words, if it says x minus 3, it means it moves it to the graph to the right 3, the same way as it would in a parabola. So if a parabola said y equals x minus 3 squared, we know that we would move that to the right 3. Okay, and the converse is true if it's positive. So if it says x plus 3, we would move it to the left 3. Okay, so that's the important thing that you have to watch out for that because it moves it in the opposite. Now the phase shift is always in degrees. So the number that you're going to have for C is going to be like 30 degrees, 45 degrees, 15 degrees. Okay, and what happens here, it affects the labeling on the x-axis. Okay, so what it creates is what we call new important values. Remember, our important values were 0, 90, 180, 270, 360, and I'm sure you're tired of me saying that. But what happens, the distance between here was all 90 degrees. Okay, now when a phase shift occurs, these values change. However, the spacing between the points will still be 90 degrees. Okay, and we're going to do some examples so you can see what happens there. Now, there's two separate methods for graphing. I do it both ways. However, well, I can do it both ways. I usually teach one way over the other just because I find it easier for students. So one way is you draw the original graph and then move every point. Okay, so that means you would actually draw two graphs. Okay, the other way is we would add or subtract the phase shift to those important values and draw one graph. And I find students find it much easier to do it this way because, first of all, you only have to draw one graph. Second of all, you don't get confused when you're looking at something because you're not sure which graph you're supposed to be looking at. So I always find the second way is much easier for students to do. Okay, so and that's the way that I'm going to teach you then. Okay, so we're asked to graph this following. Now, when I graph this, notice I haven't got anything here. Again, I look at the first thing at my vertical displacement, and you can see that there's nothing going on there. So this is the first thing that I look at, and that's our vertical displacement. And I would draw my line, my dotted line, the same way as I would before. The next thing I would look at is my amplitude, only because I'm going to get more marks if I have my dotted lines there. So my amplitude. So I would look at that second. The next thing that I would look at is how I'm going to label my x-axis. So this would be my x-axis. Oops, can't even spell it. Axis labeling. Okay, and as I said, that's the easiest way to do it. So what I'm going to start with is I'm going to walk you through exactly what I would do if I was expected to graph that. So I would need a straight line for my x-axis, even though I'm not going to put anything there. And I would also have my y-axis. So I would label them x and y. And I would put some numbers here. I know that I do not have an amplitude change, so I know it's going to be 1 and -1. Okay, and I would put my dotted lines. Nothing here, so I know that my dotted lines are going to occur at 1 and -1, and I'm going to use the x-axis. So now I need to label my x-axis. So when I do that, as I said, the easiest way is to take what we know and change it. So what I know, first of all, is my important values before were 0, 90, 180, 270, and 360. What I'm going to do now is I'm going to add the opposite. So the opposite of minus 30, I'm going to add 30 to every single one of these now. Okay, so every single one of these is going to be add 30 to every single one. Okay, and by doing that, I have created my new important values. So what I'm going to create here are the values that I truly want to graph on my x-axis. Okay, so you can see 0 plus 30, well, that's 30. Then I have 120. I have 210. I have 300. And lastly, I have 390. Now, if you notice, if I did first differences on here, if I subtracted these would all be 90. There's a difference of 90 between each one. So again, that's no big deal. Okay, my real issue is when I go to label. Okay, because before I just put my dots at 0, 90, 180. Here I can't, I have to have my first location at 30. And then I can't have my next location at 120 because once I say that this is 30, then every single tick after that is also 30. So this would be 60, this would be 90, this would be 120, which is one of the important values I wanted, right? There it is there. So what I'm going to do is I can see that after that one I have 1, 2, 3. So 1, 2, 3. This would make another 90. So that's my next point, which would be 210. 1, 2, 3. My next point is 300. 1, 2, 3. My next is 390. Okay, so that is every 90 degrees. Okay, so that would be 330, 360, 390. Okay, so, and I could go back this way and that's negative 30. Okay, so instead of starting at 0, 0, I have to start at 0, 30 because that is where this has been transferred to being started at 30 degrees. Okay, so again, I'm going to make my ping pong balls. It's not that difficult. I start at 30, and because there was nothing in front of my amplitude, I know that I'd go up, go back down. So it's just at these locations that we have our points. There we go. Oops, this one here was wrong. And I did mine wrong, sorry. 30, 120, 210, 300, 390. Okay, now you don't have to label every single one of these ticks. However, you have to show those ticks. Okay, and that's one thing that kind of threw me off a bit. Okay, so now it's just this nice smooth curve through those points. And you'll notice it'll look exactly like what we were doing before. The only difference being is we're not starting at 0, 0. So we're not starting here. Okay. Now, if we were doing it that other way I told you about, I would do this first. I would draw this and then I would move every single thing over. Okay, I would move this over 30, this one over 30, this one over 30, this point over 30, this point over 30. So you can see that it would become much more difficult to draw something. Actually, that one should have been there. So as I said, this is the easiest way to do it. Okay, so let's try doing a couple more together. Okay, the next one. Okay, again, I look at the end to see if I have anything. I have no vertical displacement. I have an amplitude change of 2. So the first thing I'm going to do is I'm going to make my axes. Oops, didn't want me to do that. That's too bad. Obviously you would use, I always find that it's easier to draw these actually on lined paper, because then the y-axis you can use actually the lines on the lined paper a little bit easier, and then just use a ruler to label this part here. So here's my y, here's my x, that's 2, that's -2. I have no vertical displacement here at all, so I just need dotted lines at 2 above and 2 below. Okay, so at +2 and -2, and our x-axis is our middle. The next thing I have to do, this time it says +30, so again I take my important values from before, which was 0, 90, 180, 270, and 360. And because it says a +30, I'm going to subtract 30 from every one of these. Okay, no, I'm not going to put -30 for each one. Okay, so we have -30 is my first one. 90 minus 30 is 60. 180 minus 30 is 150. 270 minus 30 is 240. And 360 minus 30 is 330. Okay, because my lowest number is -30, that's where I'm going to be starting. So every tick again is going to be worth 30. 0, 30, 60, 90, 120, 150. Okay, and if you don't want to keep counting by 30s, you can see that the distance between is after every third tick. So 1, 2, 3, so it's 240. 1, 2, 3, 330. Okay, and so we've got that. So this will give us one period. And now we just do our ping pong balling again. And remember that sign starts in the middle and it has to start at -30. And normally sine goes up, but we have this negative, so it means that I'm going to have to go down. So at 60 is my next point, 150 is my next, 240, 330. Okay, and you can see if you've done it correctly, you'll have one period. Okay, so it looks like an upside down sine curve when we do that. And there we are. Okay, so we've got one more to do. Now this one says cos. I'm going to ask you to change that to sine because you aren't responsible for cos. Same thing, I'm going to label my axes. And I'm going to see if I can just clone some things here. Actually, I'm going to leave that one there. And I'm going to run out of time, so we'll finish this one in a second with the next video.